Hello, grade 12. So we're going to start off with organic chemistry 12, but before that, we're going to go through different terminologies which are very important for you to know. And these are the terminologies that can get you some easy 2 marks, like free 2 marks. So please just know them, remember them, even cram them for that matter, but that is not the best option. Right? So the first definition is the homologous series. It's a group of organic compounds for which have the same functional group and whose consecutive members differs from a CH2 group. Another definition, I beg your pardon, it's the functional group. It's an atom or group of atom or a bond that determines the physical and the chemical properties of organic compounds. Another definition, it's the molecular formula, which shows the number of each element in the molecule. For example, I have highlighted C4H10. It means in this molecule we have 4 carbons and 10 hydrogens. So another terminology, we have the structural formula, which shows the arrangement of atoms and their bonds in 2D. It means in drawing. Mostly they would ask you to draw the structural formula of a certain molecule. So this is a structural formula. The lines represent a bond. The lines represent a bond, and also as you can see, these are the carbons and also they being surrounded by the hydrogens. This is a structural formula. Another definition is the condensed structural formula. The condensed structural formula shows arrangement of atoms without bonds. You just write it as CH3, CH2, CH2, and CH3, right? There are no bonds illustrated in this condensed structural formula. So, one learner would say, I haven't really understood any of this terminology, or what organic chemistry in grade 12 is about. So, I would try and explain it in my African language, which is Sotho, right? Sotho Sepedi. So, go grade 12 for now. So, what learner would say, I haven't really understood what organic chemistry is all about by reading all this definition or seeing all this definition, right? So, I would try and explain it in my African language, which is like in Sesotho, Sepedi. So, organic chemistry at 12, right? Rodila ka di homologous series. Homologous series. Tse di nang leng di-functional group, right? Tse di different ko re pila mo re bereka ka di-family, re bereka di-family tse di nang le di-different characteristics. So family e nngwe le nngwe le nngwe e na le di-characteristics tsa teng. So for the word characteristics, it can be substituted by the functional group, and also for the word family we substituted using the word homologous series. So just know hore mo grade 12 re bereka ka di-different inorganic chemistry re dila ka di-homologous series, di-family tse di-different tse di na leng di-different functional group, right? So family e nngwe le nngwe re tlo itlhalosa according to the characteristics tsa teng, gore mabitso a teng a fella bjang, o e name bjang, and o e bona bjang gore e wela under family efe. O tlo e bona ka di-functional groups, like di-characteristics tsa teng, wa ntlhala. So if ke single bond, you'll know hore ke ya ko di-alkane, right? So these are the three terminologies: the molecular formula, structural formula, and the structural formula. Mostly they're not examinable, right? What I'm trying to say is that I haven't reached any question whereby they would ask you to define a molecular formula. But just to be on the safe side, you should know what molecular formula, structural formula, and condensed structural formula is, right? So you should know, it gives you a brief of what you're going to go through in organic chemistry for grade 12. So we are going to go through different homologous series slash families which have different characteristics. The word characteristics, it can be substituted by the word functional group, right, as I've highlighted previously. So the first homologous series that we're going to start with, it's the alkanes. the family of the alkane, right? The family of the alkane have a functional group of single bond. I have illustrated using the structural formula. I have entailed that the structural formula you should illustrate it using a 2D. It means in drawing, right? The lines represent single bond because it's only one line, right? The name ends with a butane, pentane, hexane, and so forth. The general formula is CnH2n plus 2. So note that the GF stands for the general formula. Um, the general formula, you use the general formula to find how many hydrogens you have, or how many carbons you have in a molecule. The second homologous series is the alkene. Alkene, the functional group for the alkene, it's a double bond. I have illustrated using the structural formula. These are the two lines which represent the single bond. The name ends with "in." The name ends with "in." The general formula for this homologous series is CnH2n. The third homologous series is the alkynes. Alkynes, or there's no master pronunciation, right? So the functional group for the alkyne is the triple bond. This is the triple lines which represents the triple bond, right? The name ends with "-ine", pentine, hexine, methine, and so forth. The general formula for the alkyne is CnH2n minus 2. The fourth homologous series that we're going to go through, it's the haloalkane. So note that haloalkane, it's the amalgamation of two words, haloalkane. Halo, it derives from the word halogen, and alkane, it derives from the alkane. So it's a combination of halogen and alkane, right? Halogen with an alkane. So the functional group for the haloalkane, it's the single bond with halogen. This X represents the X represents the halogen. So the name ends with halogen with a bromomethane, bromopentane, chlorohexane, and so forth. The general formula is CnH2n plus 1 with an X on the other side. Note that the X represents the halogens, which are the bromine, iodine, fluorine, and also the chlorine. So we're going to go through other homologous series. We're starting off with the alcohol. The functional group for the alcohol, it's the hydroxyl group. The OH represent the hydroxyl group, right? The name ends with all, pentanol, methanol, hexanol. Just know that we are going to go through the naming part. Do not be confused or do not be shocked by what I'm saying right now. The general formula for the alcohol, it's CN H2n plus 1 with the hydroxyl. The OH represents the hydroxyl group on the other side. So other homologous series, it's the aldehyde, right? What's more special about the aldehyde is that aldehyde, the double bond of oxygen, it's always bonded with the first carbon. It's either is on the left hand side or the right hand side. But just know that if you see a double bond of oxygen bonded with the first carbon, it's an aldehyde. The functional group for the aldehyde, it's the carbonyl group. The name ends with ana. Pentanol, methanol, hexanol, and so forth. The general formula is CnH2nO. Just please note that the general formula for the aldehyde and the general formula for the ketone are the same, right? It should tell you that they have a certain relationship, right? You should be able to know that, oh, the general formula for the aldehyde and also the general formula for the ketone are the same. They're trying to tell you something, but what are they trying to tell you? You're going to find out about their relationship further going. So other homologous series, we have the ketone. The ketone have a general formula for the functional group, I beg your pardon, for the carbonyl group. Um, Ketone, it's more different from other homologous series because the double bond of oxygen, it's always bonded with the two other carbons, right, on their side. The double bond of oxygen with the carbon in the middle, it's always bonded with other two carbons or three or more, but it's always in the middle of other two other carbons on the other side. So please note that and do not forget about it. And the name ends with "-one", uh, pentone, methone, and so forth. The general formula is CnH2nO, right? Other homologous series, we have the carboxylic acid. The functional group for the carboxylic acid, it's the carboxyl group. Why am I highlighting the carboxyl group? Is because um many of us, we would try and confuse the carboxyl and the carbonyl, which are not the same, right? The carboxyl group, it is composed of the carbonyl group and also the hydroxyl group, which give us the carboxyl group. So on our structural formula, we can see we have the carbonyl group, the double bond of oxygen with a carbon is called the carbonyl group, with hydroxyl group. The hydroxyl group, it's the OH, guys. This hydrogen with other oxygen, it's called the hydroxyl group. So that's why it is composed of the carbonyl and hydroxyl, which give us the functional group of the carboxyl group. And the name ends with oic acid, methanoic acid, pentanoic acid, and so forth. The general formula is CnH2nO2. So we're going to go through the last homologous series that we're going to go through in grade 12, which is called the ester. Ester derived from a reaction called esterification. Esterification is a process which is composed of alcohol and carboxylic acid, which give us the ester. The functional group for the ester, it's the carbonyl group, right? I have illustrated the functional group of the esters using the structural formula. So as you can see that on the left hand side we have the alcohol, and also on the right hand side we have the carboxylic acid, which in combination they give us ester, right? The name ends with oate. I have written alcohol with a branch because before writing the OAT, you have to write out your alcohol, but as a branch, as an alkyl group, right? The general formula is CnH2nO2. Please note that the general formula for the esters and also the carboxylic acid are the same. It means they have some certain kind of a relationship. So we're still going to try and figure out what relationship they